To the main event of the afternoon. António Sarmento, founder of WavEC, is about to position us a bit better as to where we are at the moment with the issues that we have around net zero. So António, over to you.
Thank you very much, Stephen. Well, thank you very much also for the invitation. I'm going to share my screen. I hope, well, I cannot apparently because someone is sharing the screen. So please, maybe Jennifer or Sarah, you should remove the screen so that I can share my screen.
Yeah. Sarah, can you stop sharing your screen, please? Can you share now?
Yeah. That's okay.
Okay, good.
So please let me know if you see my screen. It should be the head, well, the first page of my presentation. Can you see it?
Yep, we can see it.
Good. So that's the topic that I chose to tell you about. I must say that I'm not an expert in solar PV at all. My entire life has been dedicated to offshore renewable energy, indeed. Initially wave energy, then later on also offshore wind. But I would like to start by doing a short presentation. Let me see if I can change the screen. Yeah, of WavEC. WavEC is my home institution. I was initially, and for many years, a professor at university, at the Lisbon School of Engineering from the University of Lisbon. And along that period, I was an academic, but then together with some companies, we found WavEC, initially as Wave Energy Center, and now WavEC Offshore Renewables. So this is formally an association of 6 companies and university. We are relatively small, we are 24 people, but we do a lot of different services, or have been doing a lot of different services over this last 17 years. We work a lot on complex systems engineering, both in instrumentation and data acquisition, site and project development, environmental monitoring and impact assessment, logistics infrastructure, strategy and policy advice, and we also do some training. And we apply this, our knowledge, these services in 3 areas. The main one is marine renewable energy, that represents more than 60%, about 60% of our activity, a small area on offshore aquaculture, and then the remaining on other ocean engineering solutions. That means projects or that are not related to either aquaculture or marine renewable energy. We have a relatively balanced source of funding between R&D projects and services to companies. We have a very extensive experience on in particular the European research area, with over 60 R&D projects and the global coordination of 6. And we have also a solid partnership in these areas with many different companies and research institutions across Europe mainly. Now, some projects that we did in the past, just to illustrate, we have been working a lot with, and for many years, with Wave Roller, you know, this Finnish wave energy technology. And we did everything, but more recently, and in relation to their prototype testing here in Portugal, we have done a lot of instrumentation and data analysis, field campaigns with ROVs, environmental monitoring and impact assessment, performance evaluation, and even funding attraction. The same or about the same with Core Power. It's a Swedish technology that will be testing their first full-scale prototype and then the first 3 device farm here in Portugal. It's about the same type of work. With WindFloat technology. This is an interesting case because it has a short history. In 2007, EDP requested a study to assist them in understanding how they should move into offshore wind. And basically, we told them, well, you should be looking into floating structures, and you should be looking into wind float. At the time, wind float was starting. So we worked with them since the beginning, and later on, we were involved in the prototype testing, and now also in the wind float Atlantic, the first farm with the 3 turbines, 25 megawatt farm. We have been working along these years again in performance assessment, O&M logistics, environmental impact assessment and monitoring. We have been working also with the national grid to develop or to lay out the export cable. And so this is similar work, but not for offshore wind. We have done, this is an example indeed that we did a lot, now 4 different projects in partnership with LOC for the Carbon Trust for the offshore wind program in the UK. And we start by doing an analysis of the existing infrastructure and logistics and to understand what would be the challenges to support a 500 megawatt farm with 10 megawatt turbines. Then we did a study on O&M, understanding whether for floating turbines, maintenance, large maintenance should be done by towing to port the platforms, or whether they should be done through heavy lifting vessels. And then we repeated this also for fixed foundation. And the second one, heavy lifting in fixed foundation. So already 4 studies that we did with LOC in these areas. And finally, just to give you an example of another type of project, this was detailed CFD modeling for the ocean cleanup, which is a Dutch technology to clean the ocean from plastics floating in the surface. So, and we have done several work with them on CFD mainly. Now, coming back to the topic of my speech today, and the first thing I would like to call you upon attention is the significant cost reduction in solar PV. And the first thing that I would like to show you is this map, which shows how much energy you can produce in a year with a 1 kilowatt peak solar panel. And what is interesting is in the lower scale, you can see that from the violet to the dark red, the scale changes by a factor of around 3.5. And if you compare, for instance, Portugal here, which is around 1700 kilowatt hours annual production, to say Scotland here, which would be in the range of 800, you see that it changes only by a factor of 2, and not more than that. And that is relevant for what I'm going to say. But now, let me tell you about prices. In 2014, in the United Arab Emirates, there was a farm that was that produced energy at 52 euros per megawatt hour. Then in the following year, we can see values ranging from 61 to 80 in very different geometries, India, France, and Germany. Later, 1 year later, in Mexico and Peru, and it went down to 32 and 43. Then in 17, again in the UAE, you see that in 3 years, the cost reduced by almost half. And in India, also in 3 years, to about 1/4. And then in Portugal last year, we had the minimum price of 14.8 euros per megawatt hour. And this year, this went down even to 11.1 euros per megawatt hour. So you see that there is this incredible reduction of energy production prices in solar PV. And I think we should understand a little bit better what this means and what will be the impact of this in the long term in the energy scenario, in particular in relation to offshore renewable energy. So let me first say a few words about the auction that occurred last year in Portugal. This was, and start by saying that our average electricity market price is 50 euros per megawatt hour. Okay, and this was an auction for 24 farms with a total installed capacity of 1400 megawatts. So it's a large competition. We had 64 competitors from around the world. The bidding base that the government set was 45 euros per megawatt hour, so below the market price. But of course, the winners would be the ones that would provide lower prices, so a higher reduction of cost. The price was fixed for the next, should be fixed for the next 15 years. So the minimum price in one of the farms was 15.8, and the average price over the 24 farms was 20 euros per megawatt. These are the areas where these farms are located. You can see that the winner was Total Solar with 370 megawatts, then Iberdrola 150, and ETP Renewables 120. Now, this year the situation was a bit different. It was less power, 670 megawatts in 13 farms, and there was different alternatives. The companies could do their offer in different alternatives. You could go only for production, so without storage, and indeed one of the farms with a total installed capacity of 177 megawatt offered this at a fixed price of, for the next 15 years, of 11.14 euros per megawatt hour, as I said before. But then in 12 other cases, they apply also with storage. And with storage, I mean, this was 493 megawatts of total installed power to be installed, with a storage of 100 megawatts. And in this case, you could go at market price. So you can sell the electricity at the price you can. You choose. But then you have two alternatives. 8 farms choose this first alternative. They compensate the state grid with this amount, 33,500 euros per megawatt hour for the connection point. So they pay for the connection point to have access to the grid. But further, they assume that they will compensate the energy system if the market price increases due to low operation of the conventional power plants. You know that because here in Portugal we have a high percentage of renewable energy connected to the grid. Most of our power plants, conventional power plants, operate only at 20% of their full capacity, which increases the cost. Then 4 farms choose another regime, and then in this regime they pay much higher price for the connection point, but they don't have to compensate. So this was, the scenario that came out. All of the companies that got this are foreign companies, most of them not yet operating in Portugal. So this is interesting. I mean, if you look into solar radiation between Portugal, Scotland, and Great Britain, this is more or less the average. I mean, this is more or less, it's not, but more or less, which says that basically if it costs 11.1 euros in Portugal, possibly it will cost 22.7 in Scotland and 20.1 in Scotland. So this is assuming that the costs decrease linearly with the solar resource, which is reasonable because the infrastructure is the same, but production changes. You can also think that, well, yes, but you need a lot of area for solar to produce electricity, and that's about This slide is about that. So let me first present you some statistics for Portugal, Scotland, and Great Britain. This is electricity consumption per year. Again, I'm not sure if these numbers are completely correct, but they should be of this order. This is the solar irradiation again, and this is the country area. So you see that for Portugal, to produce all the electricity that you consume in 1 year, we would need 135 square kilometers. That represents 0.14% of the total area, and that's about the size of Lisbon. And if you go to Scotland, these are the numbers. 0.27% of the area of Scotland, and more or less the same area as Glasgow. And for the UK, the same area as London. So you see, we are not talking about areas that are impossible. These are areas that are relatively reasonable. So it is not because solar PV requires a large area that cannot be a solution. And it is not because of the cost, because indeed the cost seems to be extremely cheap. And that creates indeed the question of what happens with offshore wind and other ocean energy technologies. So I'm looking also into offshore wind cost reduction to see how it goes. This is the wind resource in Europe, offshore wind resource in Europe, and here are some prices. 2010 in Denmark, 140 euros per megawatt hour. Then in the UK, 3 years later, 186, possibly much deeper waters, so that's why the price is bigger. Then in 2015, there was already a significant cost reduction in Denmark, not so much in the UK. Then in 16, there was a significant cost reduction in Denmark again, and also about the same in the Netherlands. In 17, then you have already a significant cost reduction in the UK and also in Germany, with one of the farms in Germany going at market price. In 2018, also in the Netherlands, a farm going into market price. And last year in the UK, big auction, 5.5 gigawatts, and the average around 45 euros per megawatt hour, which should be around also the market price. So indeed, we see that offshore wind is also reducing significantly the costs, even if it seems to be still significantly higher than what you could achieve with solar PV. So the pressure is there, and I complete here